Hello friends, in the last lecture we have studied about Coulomb's law. It is a law which helps us to find out the force of electrostatic between two static charges which are kept at some distance apart. But as we know, force is a vector quantity, so along with magnitude we need its direction also. Although we know that two like charges repel each other, whereas two unlike charges attract each other. But if it is asked to prove it mathematically, then how it can be done? For that, we use Coulomb's law in vector form. Now let us study Coulomb's law in vector form. As you can see, there are two charges Q1 and Q2 kept at point A and B in xy plane. As per the vector notations, the position vector of point charge Q1 kept at point A is R1, whereas the position vector of charge Q2 kept at point B is R2. The displacement vector from point A to point B is taken as R12. Now, let us assume that the force acting on charge Q2 is along the direction F21, and similarly the force acting on charge Q1 is along F12. So this is the basic criteria through which we'll derive the Coulomb's law in vector form. Now, as I have told you, R1 is a position vector of charge Q1, R2 is a position vector of charge Q2. So the AB, line joining A and B, is given by R12, which is found out by R2 vector minus R1 vector. Similarly, the line BA, that is opposite, will be taken as R21 equal to R1 vector minus R2 vector. अब ऐसा क्यों किया है? This is because of vector notation. As you change the direction of force, the vector or the displacement vector must also change. Moving on, we assume that the magnitude of R12 is taken to be equal to R12. This is the magnitude of vector R12. Similarly, magnitude of vector R21 will be R21 as it is written over here. Now, since we are deriving this formula to find out direction, so we need a unit vector. Let us assume a unit vector R12 cap along AB. As we know, unit vector is equal to vector upon its magnitude. Similarly, a unit vector along BA to find out force 12. R21 cap. So R21 cap is given by vector R21 upon its magnitude. Now we'll find the force acting on charge Q2 kept at B due to Q1. We have assumed that force is given by F21 vector. Here F21 vector indicates that force on charge Q2 due to Q1. So F21. Similarly, force on A is given by F12, that is force on charge Q1 due to Q2. So F12 vector. We have assumed that they are acting in this direction. So now we'll find out its magnitude. So F21 vector is given by K Q1 Q2 upon distance square. This we have learnt in Coulomb's law, that F is given by K Q1 Q2 upon D square, where D is the distance between the two charges. In this case, the distance between two charges is AB. So I have written AB square. Since it is a vector quantity, I require direction, so I have written along AB. Now K is given by 1 by 4 pi epsilon naught, where epsilon naught is absolute permittivity of free space, which we have discussed in the earlier lecture. So putting this value over here, I get F21 vector is equal to 1 by 4 pi epsilon naught Q1 Q2 upon R12. I have not written the vector, I have written its magnitude because I am talking about the distance. So R12 square, and for direction I have used R12 cap. It is a unit vector along AB. Moving on, as we know, The unit vector is given by vector upon its magnitude. So putting these values in equation 5, I get this equation. Now as I know, vector r12 is given by vector r2 minus r1. So putting this value, I finally get f21 as equal to 1 by 4 pi epsilon naught q1 q2 upon r12 whole cube into vector r2 minus r1. By using this formula, I can find out the force F21, that is force acting on charge q2 due to q1. Similarly, we can find out the force acting on charge q1 due to q2. Now charge q1 is kept at A. So we'll find out F12 vector is equal to 1 by 4 pi epsilon naught q1 q2 upon r21 whole cube into r1 vector minus r2 vector. So this is the formula of finding out force between two charges in vector notation. But what about direction? So now we'll find out the direction of the forces, for which we have derived this equation. Now if both the charges have same sign, it means the charge kept at point A and at B have same sign, or we can say both of them are like charges. Both of them can either be positive charges or both of them can either be negative charges. In both the cases, if we multiply them, we'll get a value which is greater than 0. For example, the two like charges minus 5 coulomb and minus 7 coulomb are kept at point A and B respectively. And if we multiply, we'll get our answer plus 35. It means it is greater than 0. Now, if q1, q2 is greater than 0, then F21 vector has to be positive. If it is positive, it means the direction of F21 vector and the direction of R12 cap are same. So direction of F21 vector and R12 cap are same. It means the direction which I have assumed is correct. It means if both the charges are of same sign or same polarity, then they will repel each other. But if both the charges have opposite sign, then q1 into q2 has to be less than 0. If one is positive 5 and the other is negative 7, the answer is minus 35, which is less than 0. If such thing happen, then F21 vector will be negative. So direction of F21 vector will be opposite to direction of R12 cap. It means in that case the direction of F21 vector will be along this arrow. Hence we can conclude that both the charges will attract each other. So using Coulomb's law in vector form, we can find out whether the force charges will attract or repel each other. A most important thing which you need to remember is that Coulomb force, or you can say the electrostatic force, is conservative in nature. It means that if we move the charge along any path, the net force or the net work done will depend upon only the initial and final position of the charge. This we have discussed, or you must have learned in class 11th, what are conservative force and what are non-conservative force. So you need to remember that Coulomb force or the electrostatic force between two charges is a conservative force. Moving on, now we'll define one Coulomb. Coulomb is the SI unit of charge. Now using Coulomb's law, we can find out that the force acting between two static charges or the charges which are at rest is given by k q1 q2 upon d square. Now let us assume that both the charges have charge 1 coulomb and the distance between them is 1 meter. As we know, value of k is equal to 9 into 10 is to power 9. So the force will be equal to 9 into 10 is to power 9 Newton. Now we need to write this in statement. So 1 coulomb is defined as that much charge which when placed in vacuum at a distance of 1 meter from an equal and similar charge would repel it with a force of 9 into 10 raised to power 9 Newton. If the charge is not similar, then they would attract, but the force will remain same, that will be equal to 9 into 10 raised to power 9. Now talking about CGS unit, the SI unit of charge is Coulomb, where the CGS unit is Stat Coulomb or ESU. ESU stands for electrostatic unit of charge. Now 1 Coulomb is equal to 3 into 10 raised to power 9 Stat Coulomb or ESU. The next topic, which is an important one, is the principle of superposition. Now how to find out, or what is principle of superposition? Let us assume there is a charge Q0 which is surrounded by 4 charges, or there can be more than 4 charges. Since many of the charges surrounding it, they all must be applying or exerting a force on charge Q2. So what would be the net force acting on the charge Q0? For this we use principle of superposition. यहाँ पर assume कर रहे हैं एक चार्ज है Q0. It is surrounded by 4 charges Q1, Q2, Q3 and Q4. Each of the charge will apply a force on Q0. As we know, the electrostatic force acts along the line joining the two charges. So force on Q0 due to Q1 will be along this line joining, and let us assume that it is FO1 or F01. Similarly, force on Q0 due to Q2 is along this line joining, that is F02. Force on Q0 due to Q3 will be along this line. It is given by F03. Similarly, due to Q4, it is along this line given by F04. So what would be the net force acting on Q0? It will be the vector sum of all the forces, which is given by F0. So this is the resultant force acting on Q0. I repeat, F0 is given by the vector sum of F01, F02, F03 and F04. This is your principle of superposition. So according to principle of superposition, total force on any charge due to a number of other charges at rest is a vector sum of all the forces on that charge due to other charges taken one at a time. So F0 will be equal to F01 plus F02 plus F03 plus F04 vector addition. And we know how to add two vectors. Now I've taken an example or a numerical for better understanding of superposition. इस एग्जाम्पल या इस न्यूमेरिकल से आपको और आसानी समझ में आएगा कि प्रिंसिपल ऑफ सुपरपोजिशन कैसे अप्लाई करते हैं. तो क्वेश्चन क्या है, लेट्स स्टडी. Consider 3 charges Q1, Q2, Q3 each equal to Q, means its magnitude of each charge is Q at the vertices of an equilateral triangle of side L. What is the force on the charge capital Q, whose magnitude is also Q, placed at the centroid of the triangle? So first we need to draw the diagram. This is a equilateral triangle. तीनों वर्टाइसेस पर 3 चार्जेस हैं Q1, Q2, Q3. सबका मैग्नीट्यूड हमने माना कितना है Q. हमें फोर्स किस पे निकालना है, इस पॉइंट O पे जो चार्ज है जो कैपिटल Q है. कैपिटल Q का मैग्नीट्यूड भी कितना माना गया है, आपका स्मॉल q ही माना गया है. तो अब कैसे निकालें, तो A और O को लें तो जो फोर्स एक्ट करेगा इस लाइन के अलॉन्ग एक्ट करेगा इस डायरेक्शन में, वो उसको रिपेल करेगा. रिपेल क्यों करेगा, दोनों का मैग्नीट्यूड और दोनों का साइन सेम है, मीन्स दे आर लाइक चार्जेस. तो ये डायरेक्शन मान लिया F1. सिमिलरली B पे जो चार्ज है इट विल ऑल्सो रिपेल Q अलोंग F2. सिमिलरली पॉइंट C पे जो चार्ज है इट विल रिपेल Q अलोंग F3. सो वी नीड टू फाइंड आउट द वेक्टर सम ऑफ F1, F2 एंड F3. तो फर्स्ट, as we know, according to Coulomb's law, force is given by K, Q1, Q2 by distance square. We don't know distance between A and O. So first we need to find out AO. Now how will we find out that? So as AD is a median, so here ABD is a right angle triangle. Using that we can find out AD. तो AD यहाँ से आएगा AB sin 60, that is √3L by 2. Now AO, as we know, the centroid divides the median in the ratio 2:3. So AO is equal to 2/3 AD. वहाँ से आया L by √3. तो अब A और O के बीच में डिस्टेंस कितना हो गया, L/√3। सिमिलरली B और Q के बीच में डिस्टेंस कितना हो गया, L/√3। और C और Q के बीच में डिस्टेंस या C और O के बीच में डिस्टेंस कितना हो गया, L/√3। फिर से बोलता हूँ, A और O के बीच में डिस्टेंस L/√3, B और O के बीच में डिस्टेंस L/√3 एंड C और O के बीच में डिस्टेंस L/√3। तो पहले फोर्स ऑन कैपिटल Q ड्यू टू A, तो इस तरह से निकल जाएगा अलोंग OA। सिमिलरली Q2 को अक्रॉस निकाला, वो मिल गया F2 और हमें मिल गया F3। ये तीनों हमने फोर्स निकाल लिए, तीनों का मैग्नीट्यूड सेम आएगा। अब F2 और F3 के बीच में एंगल कितना है, वो है 120 डिग्री। ये आप सिंपल जियोमेट्री लगा के निकाल सकते हैं, वो आएगा 120 डिग्री। यहाँ से ये एंगल निकलेगा, इसका ये वर्टिकली अपोजिट, ये एंगल इसका वर्टिकली अपोजिट, 60 आएंगे, दोनों का ऐड करेंगे 120 बन जाएगा। तो हमें क्या बताया प्रिंसिपल ऑफ सुपरपोजिशन में, वेक्टर सम। तो F2 और F3 का वेक्टर सम निकालेंगे तो वो ये आएगा F नेट, ये आ गया F नेट अलोंग OA। तो ये आ गया अलोंग OA। अब ये F नेट और ये F1 दोनों का मैग्नीट्यूड सेम है, दोनों एक दूसरे के वर्टिकली अपोजिट है। तो जब सॉल्व करेंगे तो आंसर क्या आ जाएगा, 0। मीन्स द नेट फोर्स एक्टिंग ऑन Q ड्यू टू ऑल दीज चार्जेस विल बी इक्वल टू 0। मैंने यहाँ पे डायरेक्शन नहीं निकाला है F नेट का, आप निकाल सकते हैं बाय यूजिंग tan थीटा फॉर्मूला जो आपके वेक्टर में कराया गया था। तो अब उसको निकालेंगे, F2 ये होगा F1 sin थीटा प्लस F1 cos थीटा, उससे आपको इसका आंसर मिल जाएगा। इस चीज से tan थीटा इक्वल F1 sin थीटा अपॉन F2 प्लस F1 cos थीटा से आपको इसका आंसर मिल जाएगा। और इससे फाइनली टोटल आएगा F नेट माइनस F1 इज इक्वल टू 0। तो इस तरह से आप प्रिंसिपल ऑफ सुपरपोजिशन यूज करेंगे, यानी हर एक चार्ज के कारण विल फाइंड आउट फोर्स, देन विल वेक्टर एडिशन से नेट फोर्स निकाला जा सकता है। Thank you friends for listening patiently. In the next lecture, we would be studying about continuous charge distribution in electric field. Thank you.